Hi everyone. For this video we're going to be looking at continuous functions, well more specifically points of discontinuity, and we're going to be looking at why these things are discontinuous, or these functions are discontinuous. So let's take a look at this graph here. So remember, a function is continuous if you use the pencil test, right? And that's just a quick way of figuring out. So this graph you can see is discontinuous at certain points here, because if I were to take my pen or pencil and follow this function, right, and trace this function, notice I have to lift there, so there's a point of discontinuity there. And if I keep going, I have to lift again, keep going, I have to lift again. Okay, so notice there are points of discontinuity here. So there's this asymptote, there's this hole, and this hole. Alright, so we're going to talk about why continuity, for each of these, why continuity condition fails. So from this pencil test that we just did, there are 3 points of discontinuity that we're going to be looking at. So the first one is x equals 4. That's where this asymptote is. Alright. The second one is x equals 5. And the third one is x equals 7. So before we actually talk about what conditions they fail and all that, let's kind of do a brief review from the notes. So hopefully you've looked at the notes. And so when we look at what continuity is, remember there are 3 things that we look at. So the first thing is that f of c is defined. So what that means is that if I'm looking at a graph, that there is a y value or a point on the graph that exists. Alright? And so that's the first condition. The second condition is that the limit of f of x, or of that function, as you approach that value, so x approaches c, also exists. Okay, so we'll talk about what that means more specifically. But basically, as you approach a x value of some kind, there is a y value that exists. Okay, and then the third condition that you should have seen in your notes is that conditions 1 and 2 are equal to each other. So the limit of f of x as x approaches c is equal to f of c. So notice we're saying that these 2 things have to be equal to each other. Okay, so these are the conditions that we're talking about, and when we talk about where does it fail, where does continuity fail, and we're talking about these 3 conditions. So let's go back up to these discontinuities that we have here. So from the pencil test, we know that these are 3 points of discontinuity because I have to lift up my pencil or pen every time. Alright, and it's not a continuous function. So let's take a look at these 3 conditions for each of those points. So at x equals 4, we're looking at right here, right? We're looking at this vertical asymptote. So the first condition says f of c is defined. So it's asking, is the function defined at x equals 4? So because it's an asymptote, it's not actually defined anywhere there. It doesn't exist at x equals 4. So it automatically fails the first condition. So I'm going to write it violates condition 1. Now, just because it violates condition 1, it doesn't mean you don't check the other conditions. You still need to check the other 2. So we're going to look at the second condition. So we're going to look and see here, does the limit exist as we approach 4? So as we approach 4, remember what that means is we're looking at from the left side and from the right side. So from the left side, if I'm coming from the left, I am approaching infinity. Okay? What y values am I approaching? As I get closer and closer to 4, y values are approaching infinity. From the right hand side, it's the same thing. As I get closer and closer to 4, I am also approaching infinity. Now, at this point, you're probably like, oh, well, then the limit exists, right? But remember, if we're approaching infinity, it doesn't technically exist because infinity is not a y value. And so it actually fails this condition as well. Okay, because it doesn't actually exist. And then the third condition, remember, is do they equal each other? Well, if the first condition doesn't exist and the second condition doesn't exist, well, they can't equal each other. They doesn't exist, so it also violates condition 3. So that point of discontinuity at x equals 4, it violates conditions 1, 2, and 3. Okay, so let's take a look at what's happening at x equals 5. So we're looking at this right here. So the first thing is it defined at x equals 5? That's the first condition. Well, it actually is. So even though right here you see a hole, right, when x is 5, it does exist. There is a solid circle there, which means that when when x is 5, then the y value is 5. So it does exist. Okay, so it passes the first condition. All right. The second condition, remember, is the limit. Does the limit exist? So we're going to look at it from the left side and from the right side. Okay, so from the left side, if I approach x equals 5, I am getting closer and closer to a y value of 1. Okay, so from the left side it equals 1. But from the right side, as I approach 5, my y value is 5. So because they don't equal each other, it violates that condition because the limit does not exist. So we're going to say it violates condition 2. Okay. And then condition 3, do they equal each other? Well, in condition 1, we said that f of c is equal to 5, right? So c in this case is 5. So when x is 5, your y value is 5. But the limit doesn't exist. So they can't equal each other, so it actually fails condition 3 as well. And then the last point of discontinuity is when x is 7. So if I look at when x is 7, I'm looking at this right here, the first thing I'm going to do, is it defined at 7? Well, when x is 7, I don't see where it exists, so it actually fails the first condition. So it violates condition 1 because it doesn't exist. Now let's check and see if the limit exists. So again, I'm going to check from both sides. So from the left side, the limit looks like it's approaching a y value of 7. From the right side, it's also approaching a y value of 7. So the limit does exist. So it does not violate the second condition. And then the third condition is, can they equal each other? Well, if the limit exists, but then the function's not defined at that point, they can't actually equal each other. So it does fail condition 3 as well. Okay, so make sure you check all 3 conditions whenever you're looking at points of discontinuity.